This is Saritha, working as Assistant Professor in EC Department, Institute of Aeronautical Engineering, Dundigal. So today I am going to explain about types of optical fibers. So in that we are having different types of optical fiber. Optical fibers are there. So what is mean by optical fiber? So optical fiber in this it consisting of core cladding. So the light is incident on the core. So here this part light ray. So light ray incident on the core, air core. This part is nothing but air core interface, and this total part it is a core, and the core total core covered with the cladding. So cladding has a less refractive indices and core is a high refractive indices. So the wave is transmitted in refraction method. So here the total core, entire core is covered with cladding, and cladding is covered with plastic coating. So this is the basic structure of the optical fiber. So in this optical fiber, how we can transmit the signal, how we can communicate, transmit the information from one place to another place by how we are using optical fiber for the communication. So in that basic, what are the basic blocks involved here? Transmitter and receiver. Between the transmitter and receiver, we are using optical fiber. Through optical fiber, we can transmit the information in the form of light. So in that transmitter, we are transmitting the information 0101. If it is digital, the data is transmitted in the form of pulses, on and off conditions. If it is analog, that analog data we can convert it by using encoder. Then that analog data converted in digital form with the help of encoder. That binary data is transmitted in the form of pulses, on off conditions. In optical fiber we are using, so the light, here light source, this light source, the signal is enters incident at the air core interface, and cladding has a less refractive index, then it is refracted, and again it is refracted, so the signal is transmitted through optical fiber in the phenomenon of refraction method. So here across the receiver, in light detector, it receives the information in the form of light only. So by using again it converts a detector, it converts a light in the form of electrical. So the receiver receives the information and it is 0101 only. So this is the basic block diagram we are using in optical communication. In that optical fiber we are having different types. We can divide it optical fiber based on materials we are using and number of modes and refractive indices profiles. Here depending on materials, we are having two types: plastic optical fiber and glass optical fiber. So number of modes, single mode and multi-mode. In single mode, the data is transmitted only in one path. In multi-mode means we can transmit the data in different modes. And depending on refractive index profile, we can divide into two: step index and graded index. So depending on refractive index, here, cloud has a high refractive index than cladding. So, depending on that refractive index values, we are divided into two types. One is step index, another one is graded index. So, here there are three types of optical fiber cable commonly used: single mode, multi mode, and plastic optical fiber. So, transparent glass or plastic fibers which allow light to be guided from one end to another end with minimum loss. So, we are transmitting data in with the use of optical fiber. The losses are very less. And here how we are transmitting the information. So electric signal, and by using encoder, electric information can be converted into light, and by using optical fiber, it is in step single mode or multi mode based on our requirement, based on our application. We are using single mode optical fiber or multi mode optical fiber. We can transmit the information at the receiver, light to convert it into electrical form. We are receiving the electrical information. So this is the basic structure of the optical fiber, basic communication diagram of optical fiber. Here this part is, it is core, and this part is cladding. So this part is core means the total information is transmitted within the core only, within the core only. This is nothing but Total internal reflection. The total information is transmitted within the core. So it is the total internal reflection. The clad is covered entire core. See here, the cladding is covered entire core. So fiber optic cable function as a light guide. So guiding the light introduced at one end of the cable through the other end. So the light source can either be a light emitting diode or laser. So if the information source it is in the form of a light LED means it is the signal it is in the form of pulses only, on and off condition. On and off condition, the light is transmitted is on and off condition means zeros and ones. So zeros and ones, the light source is pulsed on and off, and a light sensitive receiver on the other end of the cable converts the pulses into the digital ones and zeros of the original signal. So even laser light shining through a optical fiber optic cable is subjected to loss of strength primarily through dispersion and scattering of the light. So dispersion and scattering of the light within the cable itself only. So we are transmitting the information in within the cable only. So when scattering and dispersion losses are there, so while the signal is transmitted in the form of refractions only, at that refraction some scattering losses and some absorption losses are there. So those losses occurred within the cable only. So the faster the laser fluctuates, the greater the risk of dispersion. So light strengthness, the intensity of the light can be increased with the help of repeaters only. So in optical, by using optical fiber, we are transmitting high frequency signals. Then the light intensity can be increased by using the repeaters. So repeaters we are using middle of the optical fiber. So the transmission is 100 kilometers, thousands of kilometers are there. So between the 100, each 100 kilometers or 10 kilometers, we are using repeater circuits. So by using those repeaters, we can increase the signal strength. So by using these repeater circuits, we can reduce the losses of the signal. In single mode optical fiber, in optical fiber, depending on modes of operation, we can divide into two types: single mode fiber and multi mode. So in single mode fiber, the diameter of the core is very small, so that is in the form of 8.3 to 10 microns, that has a single mode transmission, that is a one mode of transmission. So single mode fiber with a relatively narrow diameter, so that is 8.3 to 10 microns, and it propagates typically 1310 or 1550 nanometers. So it carries the high bandwidth rather than the multi-mode fibers, and it has the losses of but requires a light source with a narrow bandwidth, narrow spectral width. So narrow spectral width means in that core, the diameter of the core is very small. Here the spectral width also narrow. So this single mode fiber, it is also called as monomode optical fiber or single mode optical fiber, single mode optical waveguide, or and unimode fibers. So single mode optical fiber, it has less diameter. The diameter is 8.3 to 10 microns only. Here the propagation, it is typically 1310 to 15 nm than 1550 nanometers. So in single mode optical fiber, we are using basically for the application for wavelength division multiplexing. In that wavelength division multiplexing, each channel carries only one information. So single mode fiber gives a higher transmission rate and up to 50 times more distance than multi-mode. So by using single mode optical fiber, it transmits a longer distance compared to multi-mode, but it also cost is also more. So single mode fiber has a much smaller core than the multi-mode. The small core and single light wave virtually eliminate any distortion that could result from overlapping light pulses. So providing the least signal attenuation and highest transmission speeds of any fiber cable type. So in this single mode optical fiber, if any overlapping or any distortions are there, So virtually it light pulses virtually removes the distortion, and it provides the less attenuation and high data speed. Next, multimode cable. So in that multimode cable, we are transmitting the waves in different modes. At the transmitting side, we are transmitting in same point, but across the receiver side, we are receiving in different paths here. In multimode cable has a little bit bigger diameter with a common diameter into 50 to 100 micron range. For the light carry components, so generally in US, the size of the core is 62.5 micron. So most applications in multimode fiber is used to fibers are used. Wavelength division multiplexing is not normally used on multimode fibers. And here, plastic optical fiber is a newer plastic based cable with premises performance similar to glass cable on very short runs but at a lower cost. So in multimode fibers, the speed of here is 100 Mbps to gigabit to 275 meters to 2 kilometers over medium distances. So by using this multimode fiber, we can transmit the medium distance only. So in multimode core diameter is 50, 62.5 and 100 micrometers. So here long cable runs multiple paths of light can cause signal distortion at the receiving end, so resulting in an unclear and incomplete data transmission. So designer now call for single mode fiber in new application using gigabit and beyond. So in multimode fibers, it has in different modes, and this is one mode. So this one is one mode. In different modes of operations are there. What about in single mode fiber? In single mode optical fiber, the data is transmitted only one way only, one path only. So this is for single mode, and another one is for multi-mode path through fiber. So next one is total internal reflection. So what is mean by total internal reflection? The total light is transmitted within the core only. So depending on this core and cladding. So core has high refractive index than the cladding. So based on this refractive indices, we are dividing to two types. So one is step index optical fiber, another one is graded index optical fiber. So here total internal reflection confines light within optical fibers similar to looking down a mirror made in the shape of a long paper towel tube. So here because the cladding has a lower refractive index, light rays reflect back into the core. So the light rays reflect back into the core if they encounter the cladding at a shallow angle. So red lines. So here it shows the red lines. So here the light is incident on the air core interface and it is reflects. The reflected light we are representing with red color. A ray that exceeds a certain critical angle escapes from the fiber. So escapes from the fiber, here critical angle is nothing but we are representing with yellow color. So step index, in this step index and graded index. So step index multimode fiber. In step index multimode fiber, here the diameter of the step index multimode fiber, here it is 100 microns in a diameter. As a result, some of the light rays that make up a distal pulses may travel a direct route. If you are using distal pulses, they travel in direct route, whereas other zigzag as they bounce off the cladding. So here these alternative pathways causes the different grouping of light. So here in step index fiber, the waves are transmitted in grouping of different paths and referred to as modes to separately at the receiving point. So at the receiving point, we are getting in different points, separate points, the pulse and aggregate of different modes being to spread out, losing its well-defined shape. So in step index multimode fiber, here the wave is incident, the light is incident at air core interface, and the refractive index of cladding is very less compared to the core. So it is it is interface at the air core cladding interface, and it is reflected back, and it is again it touches to the core cladding interface, again it is refracted. So like this we are receiving multi paths here. Grouping of light pathways causes the different grouping of lights. So at the ending point we are receiving separately, we are receiving at the ending point. So these needs to leave spacing between pulses to prevent overlapping limits bandwidth, that is the amount of information that can be sent. So consequently, this type of fiber is best suited for transmission over short distances. So this step index optical fiber basically used for short distance transmission only. Next one, graded index multimode fiber. So in this graded index multimode fiber, the light is incident at the air core interface. Again, it interfaces the core cladding interface. Core has more refractive index than cladding, and gradually the wave is decreases and reaches to the middle point. Again, it gradually increases. So like that, the wave is transmitted from source to destination. This is nothing but graded index multimode fiber. So it contains a core in which the refractive index diminishes gradually from the center axis out towards the cladding. The higher refractive index at the center makes the light rays moving down the axis advance more slowly than those near the cladding. So rather than the zigzagging of the cladding, light in the core curves helically because of the graded index. Because of the graded, here the formation of the light rays are it is in the form of helically because of the graded index, reducing its travel distance. So the shortened path and the highest speed allow light at the periphery to arrive at a receiver at about the same time as the slow but straight rays in the core axis. This is straight one. This is straight ray. Light is transmitted straight way in this point, and here the light rays are interface the core cladding interface. Again, it reaches to the center point core. Again, it reaches the center point core. So like this, the data is wave is propagated. Single mode fiber. In single mode fiber, here only single mode. The light is incident at the air core interface and reaches only one mode. This is nothing but single mode fiber. Multi-mode means the light is transmitted in different modes of operation. Is called multi-mode. So it is nothing but single mode optical fiber, and the waves are like this. It is multi-mode optical fiber. So here single mode fiber has a narrow core, and the index of refraction between the core and cladding changes less than it does for multimode fibers. So light thus travel parallel to the axis. So the light is travel parallel to the axis, creating little pulse dispersion. Basically using telephone and cable television networks install millions of kilometers of this fiber every year. Here overview of the step index fiber and graded index fiber and single mode fiber. So in this step index fiber, the core size is more only 200 micrometers. So when we are using graded index fiber, the core size is 50 to 100 micrometers, and when we are using single mode, the core size is very small, that is 10 micrometers. Here generally in single mode optical fiber, here 8.3 to 10 micrometers only. So here in step index fiber, the wave is transmitted in different modes, and graded index fiber, it follows the middle line, that is core, and this is single mode optical fiber. Features of single mode, comparison of single mode and multi-mode optical fibers here. Core and cladding sizes. So here in multi-mode, core and cladding sizes are 50 to 125 micrometers or 62.5 to 125 micrometers. In single mode, 9 by 125 micrometers. So wavelength of in multi-mode 850 nanometers and 1300 nanometers. In this we are using LED sources. So in single mode optical fiber here 1310 nanometers and 1550 nanometers. Here in single mode we are using laser. So laser has only one wavelength, it is straight line transmission. LED, it is the signal, it is in the form of pulses 0 and 1. We are using multimode. So bandwidth of multimode up to 4 gigahertz, and here in single mode it is 1 lakh gigahertz. And distance determined by cable equipment and data protocol, typically under 2 kilometers, and single mode typically over 2 kilometers. Benefits, what are the advantages of this multimode is less immune to contamination, less expensive, low cost. So in single mode also lower cost, high signal quality, high bandwidth. So in that single mode we are using the diameter size is also small. Then here we are using laser. Then the speed of the light is increases, bandwidth utilization is also more, cost is also less compared to multimode. And applications, data centers, 10 GB, 40 GB and 100 GB Ethernet protocols, and multi-channel audio digital interface, digital audio purpose we are using, and CCTVs, security systems also we are using this multimode optical fiber. In single mode fiber, low haul network, outside broadcast, ENG news, news and sporting and live events. So these are the differences between features of multimode and single mode optical fibers. So in single mode is the light is transmitted in only one mode. Multi-mode means different paths. So the light forms a grouping in different paths. So this is in multi-mode. These are the types of optical fiber. So we are dividing into based on material. Optical fiber divided into plastic and glass. Based on mode, single mode and multi-mode. Based on refractive index, we are dividing to step index and graded index multi-modes. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.